So here's an example of if you were supposed to draw your own Lewis structures and figure out the formal charges with it. So here's sulfur dioxide, and according to the Lewis structure steps, this is what I would have gotten. And if I look at the formal charges for this structure, if we look at the oxygen first, the one that's double bonded, I see it's a formal charge of 0. You may have remembered this from the last example with sulfuric acid. And so let's keep going. Let's look at the formal charge for this oxygen. It's -1 because I have 6 valence electrons, -1 bond, minus 6 unshared electrons. So what's the formal charge of the sulfur? It's +1, 6 valence electrons minus 3 bonds minus 2 unshared electrons. And so that has a +1 charge, which works because this is +1 -1, and it's an overall neutral molecule. However, if we were going to try to make formal charges as close to 0 as possible, we can try and use double or triple bonds. Now, where would that come from? If I use this pair of electrons to make a double bond, then that doesn't help this. I don't know if that would help that Lewis structure. But if I made the Lewis structure, I know that if I had two pairs of electrons here, this is a 0, so I can make it this oxygen a 0 if I make this a double bond using a pair of electrons. And so what I would get would be a structure with two double bonded oxygens here. And if I check my formal charges, those two double bonded oxygens would be 0, as I calculated before. And then for my sulfur, it would also be 0 because I have 6 valence electrons minus 4 bonds, the two double bonds, and 2 unshared electrons. And so I would get a preferred structure here with formal charges all 0. And in fact, sulfur dioxide it's a bent structure with equal sulfur-oxygen bonds, and they're shorter than normal sulfur-oxygen single bonds. So this is the preferred structure.